understand this process of nucleosynthesis, which is how atoms get made, different kinds of atoms, let's go back and do a little bit of review about atoms to start with. This is a picture of the periodic table of the elements, sometimes called periodic chart. We're going to take a close look at helium and carbon, just so that we can compare them. So there's where they are on the periodic chart. Helium. Here's what its box looks like. So we need to know what those numbers mean. First of all, the 2 at the top is helium's atomic number. It tells us how many protons are in helium's nucleus. So there are 2 of them. Then down at the bottom, there's a number that's called the atomic mass. And that gives you the average mass of one atom. And it's measured in atomic mass units, which means 1 proton weighs 1, has a mass of 1. Well, if helium has 2 protons in its nucleus, but it has a mass of 4, we know that it has 2 neutrons that don't have any charge. And then, of course, it's got electrons, 2 electrons, so that it's balanced between the protons and the electrons. Okay, so let's try it on another one. There's helium. Oh, before we do that, those protons are positively charged. And so they push against each other. And they want to push away from each other because positive charges repel. So in order to make helium, the sun has to take 2 hydrogen atoms. Hydrogens each have 1 proton, but they don't like each other. They're pushing each other away and they're repelling. So all of the pressure and the heat, the intense pressure and heat from the sun pushes those protons together even though they repel each other. And this is the process that we call nucleosynthesis. And it makes 1 helium atom from 2 hydrogen atoms. Now let's look at what it would take to make carbon. Carbon has an atomic number of 6. So it has how many protons in the nucleus? It has 6. Its atomic mass is 12. Each proton is 1 AMU. So that tells us that it has 6 neutrons in its nucleus. And of course it has 6 electrons around the outside attracted to the protons. Now imagine how much pressure and heat from the sun has to be used to force all those protons together. So we looked at helium and carbon. What if we go to the bigger atoms in the periodic table? So we go down and let's look at iron. Iron has an atomic number of 26 and it has an atomic mass of almost 56. Well, it turns out that the iron nucleus is larger than carbon or helium. It's got 26 protons in it and 20 up to 30 neutrons in it. There are some that have 26 and there are some that have 30 and everything in between. Now imagine the pressure and temperature it would take to make iron, an iron nucleus with all those protons repelling each other. In a smallish kind of star, a red one, a cooler star, it's only got so much pressure and temperature to force the protons together. Now in a moderate sized star like our sun, there's more pressure and temperature. And our sun can make can make atoms through about carbon size. It doesn't have enough temperature or pressure to make atoms that are any larger than that. To do so takes huge, massive stars, the blue ones that are really, really hot, and they have enough pressure and temperature to make the larger atoms.